Okay, so well, one of the most interesting applications of trigonometry is the right triangle problem. And of course, we have the basic flagpole problem right here. We're being told to point 10 feet from the base of a flagpole. The angle of elevation to the top of the flagpole is 67.4 degrees. And find the height of the flagpole. Well, okay, what does that mean for us? When we say angle of elevation, if you were looking out at an object, and here's a stick Professor Peoples looking out at an object using his mad trigonometric skills. Well, if you go straight out, of course, you've got the horizon, 0 degrees. When we look up and we see something at an angle, we call that angle our angle of elevation. So an angle of elevation is how many degrees above the horizon we see an object above it. And if we were to look down, by the way, I'll use a different color right here, but if we were looking down to find an object, we sometimes call that an angle of depression. Angle of depression. And it has nothing to do with the mental state. It has everything to do with the trigonometric values of our angles. So what do we want to do right here? Well, we're saying, okay, so somebody's standing 10 feet from the base of a flagpole. And so we got somebody standing here from the base of our flagpole looking up and at our angle up we see, and I'm exaggerating it quite a bit, but okay, we have 67.4 degrees. We have 10 feet from the base of that flagpole. So we're interested in how high is that flagpole. Well, this is really nothing more than the problem that we solved before. If we're interested in x, this is our opposite side of our right triangle. Of course, that 10 feet that we were given is our adjacent side. Pretty cool. So we can use our ratio again for the tangent. This time our tangent of 67.4 degrees, and that's going to give us our opposite side, and I called that x in this problem, and our adjacent side, which is 10 feet. So whatever we get for the tangent of 67.4 degrees, we're going to multiply that by 10, and we're going to get the height of that flagpole. So let's try it out right here. I'm going to go ahead and use my calculator to get this one. What will I say? Well, in this case, 67.4 degrees. I'm going to take my tangent of that angle. I'm going to multiply it by 10. And I get 24.02. 24.02. So we would write 24.02. That's actually the angle or the value for x, but we probably want to round to the nearest whole foot because we're really just using this as an estimate. So we'd say approximately 24 feet high. As the height of our flagpole. So there we go. So let's try a separate application this time. Let's try this idea right here. That's this angle of elevation to the top of the Cheops, pyramid of Cheops is 36.4 degrees, measured from a point 350 feet from the base of the pyramid. Now, if we actually go to the angle of elevation from the base of a face of the pyramid, we get 51.9 degrees. So I've got this diagram right here, and I see that my angle that I'm talking about in the first part of the sentence is right here. We're saying we've got 36.4 degrees right here, this part of our triangle. And that point is 350 feet from the base of our pyramid right here. So if we draw a little line right here, that's 350 feet right there. Then we make another little line right here from the face of the pyramid, and this angle that we find right here happens to be 51.9 degrees. So the question is, well, how tall is our pyramid? Well, now we've got a slightly different problem, right? Because we haven't got a nice right triangle. What do? Well, in this case, this is actually going to be a little bit more interesting for us because what's happening is that we don't know this particular length, but we do know a couple of things. We know that whatever this length is down here, we don't know exactly what that is from the center of the pyramid on out there. Whatever it is, right, that length will be equal to, will give us something like a tangent problem like we just dealt with. So we're going to set this up as a right triangle problem. I'm going to actually have two right triangle problems here. The way it's going to work, I'm going to call this height of our pyramid equal to h. And so what would we say? Well, I know that if I took the tangent of my angle 51.9 degrees, I would be getting h over x, the height of the pyramid over x, which is that unknown distance for the part of the base of the pyramid. But I also know that if I take the tangent of 36.4 degrees, that's equal to the height of the pyramid divided by 350 feet plus x. Okay, so that's that long side of the right triangle that I have right here. So what I'm going to have to do if I'm interested in finding h is I'm going to have to take an intermediary step. I can actually get these values right here. I'm going to do that. Tangent of 51.9 degrees. What do we have there? Well, tangent of 51.9 is about 1.28. So I'll make this 1.28. And the tangent of 36.4, well, 36.4, we take the tangent and we get 0.74. I'm going to round that to 0.74. So 0.74. So if I'm interested in estimating my height, I actually have two algebra problems to solve. I've got h is equal to x times 1.28 in one case. So x is equal to h over 1.28. And in the other case, from this perspective, I've got h is equal to 0.74 times 350 plus x. Well, what could I do? Well, in fact, I could just take these two right here and set them equal, find x, and then use that to find h. So let's do that. I could say that right now, 1.28 times x is equal to 0.74 times 350 plus x. So let's just solve the algebra problem right here. 1.28x is equal to, I multiply and I get 0.74 times 350, which is about 258, plus 0.74 times x. And what I'm going to do is I'm going to subtract 0.74 from both sides of my equation. So this becomes 0.54x over here on the left is equal to 258. So solving for the value of x by dividing by 0.54 gives me x is equal to approximately 477.78. But of course, if I were to estimate right here for x, I'm just going to take 477.78 would be equal to h over 12.8. So I'm just going to go ahead and multiply that by 12.8. Okay, so when I multiply both sides by 12.8, I get way too big a number. Anybody see what the error was? Yeah. Well, I'll let you guys, somebody catch that for me right here, but there is certainly an error right here. And for extra points, you guys can catch it. All right. What should h actually be, though? Well, you tell me as an answer in class, and I'll see you there next time. Have a great day. Good luck with the homework, guys.